Marina Bay Sands, Art Science Museum, Singapore Flyer, Esplanade, Malayan Park, Gardens by the Bay, Jewel Changi Airport, Botanic Gardens, Singapore Zoo. Which of these attractions will emerge as the top tourist attraction in Singapore? What are the sentiments tourists have towards these places? Let's find out. In order to identify top 11 tourist attractions in Singapore, we employed the following workflow with 4 main phases. Firstly, data collection. We use keywords such as Singapore travelling and we scraped posts from Xiaohongshu. From there, we gathered 11 hotspots based on a frequency. In phase 2, we did data pre-processing where we removed duplicate data, bot-generated posts, converted the posts to simplified Chinese, we removed stop words using a dictionary, we did word segmentation, and also removed special characters and redundant symbols like emojis. Subsequently, in the third stage, we did text analysis, namely high-frequency word analysis and sentiment analysis. Under the umbrella of high-frequency word analysis, we filtered the location, we did a cold word matrix, subsequently leading to a semantic network analysis, and then we also did activity type statistics. Subsequently, the results are as seen below, where we have the 11 popular tourist attractions, we did a semantic network diagram, activity richness portrait, and also sentiment distribution of Singapore's attractions. We use Selenium, which is used for web scraping by automating web browser actions. Firstly, we first got the links of the post under a certain keyword, and then we got the information by links as seen in this slide. As a result, a total of 9,263 Xiaohongshu posts were scraped, and from there, you can actually see the tourist attractions as listed here. Let's explore our pre-processing stage. Firstly, we remove duplication by using the drop duplicates method in pandas to ensure unique entries and eliminate redundancy. Then, we consulted various literature to detect and remove bot-generated posts by performing aggregate analysis using the date field. So for example, if a user posts the exact same post 10 times a day, we'll consider that account as a bot and we will remove posts from that account. Next, to standardize the entire content, we converted all the text into simplified Chinese by using the OpenCC library. Next, to further streamline the content, we applied the HIT stop words list from GitHub to remove common non-essential words so that we can focus on the contextually meaningful terms. Then, we removed all special characters and redundant symbols to further clean the text, and lastly, we used Jiepa and Tulek for word segmentation and part of speech tagging to break down the sentences into meaningful word units and prepare the data for accurate sentiment and topic analysis. And now, this is the moment that you have been waiting for. Where are the top 11 tourist attractions in Singapore? Drumroll please! And here they are, from Changi Airport, Sentosa, Marina Bay, Singapore Zoo, Chinatown, Orchard Road, Little India, Malayan Park, Marina Bay Sands, Clarke Quay, and National Gallery Singapore. Alright, now let us unveil the different types of activities that are most popular in Singapore and which tourist attraction offers the most amount of tourist activities. So in order to do that, we used Python for high-frequency word analysis, specifically using Tulek, a segmentation tool developed by Tsinghua University for Chinese word segmentation and part of speech tagging. From there, we unveiled that Sentosa, Marina Bay Sands, and Marina Bay have the most amount of tourist activities available, while Orchard Road, Malayan have the least amount of tourist activities available. And then we found that the most popular tourist activities in Singapore are sightseeing, food, shopping, and photo taking. These are the pie charts summarizing the activities at each of the attractions. Next, moving on to sentiment analysis. We use two main tools to help us with our sentiment analysis. Firstly, we use TF-IDF, which stands for Term Frequency Inverse Document Frequency. So TF-IDF effectively emphasizes unique terms that represent a document's core content, helping to filter out irrelevant information and highlight key features. Then, we use PySenti Sentiment Lexicon, which integrated several prominent dictionaries including the HowNet Sentiment Dictionary, Tsinghua University's Li Jun Sentiment Dictionary, and Boson NLP, which offers extensive sentiment-related vocabulary adapted to multiple languages and contexts, making it highly suitable for diverse sentiment analysis applications. From there, sentiment scores were then calculated and normalized to a range of -10 to 10. So based on these scores, sentiment was classified into 5 categories, namely highly positive, positive, neutral, negative, and highly negative. So this is the sentiment analysis results that we have. Overall, Singapore's attractions receive a high proportion of positive feedback, especially in the very positive category. Then, we realized that there were higher neutral rankings for certain attractions such as Marina Bay, Malayan Park, and Orchard Road. Then, we also realized that there was a greater appeal of natural and cultural attractions, where attractions with natural or cultural appeal such as Singapore Zoo and Little India had higher positive ratings. But commercial or tourist hotspots like Orchard Road, Malayan Park, and Marina Bay showed more neutral and negative ratings. We also realized that most attractions in Singapore had very low negative and very negative ratings, generally below 0.02, and the reasons for these negative ratings stem from the high cost, it being crowded, hot, the queue, bad tasting, and it being unsafe. This is the co-occurrence image perception table of the 11 scenic spots in Singapore, where we looked at the top 50 high-frequency word pairs to get an initial idea of Singapore's tourism image. So we examined 6 key aspects to observe what makes certain attractions stand out and what attracts visitors. For example, we see that Marina Bay and hotels are top destinations that attract a lot of attention, and we also see that iconic spots like the Malayan and Changi Airport's waterfall showcase Singapore's unique appeal, and that also we can identify that people enjoy free attractions, cultural sites, and easy to access hotels, and that parks are a favorite place for photography. Alright, so over here you see that Marina Bay and Garden is one of the highest pair words, which indicate the strong appeal of Gardens by the Bay and also Singapore's hotel facilities to tourists. Next, we also see Park and Malayan, where because Malayan is one of Singapore's most iconic statues, strongly associated with parks as well. Alright, and then we also can observe how tourists actually prefer unique experiences and travel convenience, and they also have preferences for specific activities. Subsequently, we also did semantic network analysis, where we used 6 indexes of semantic networks with Gephi to calculate them. So these 6 indexes include average degree, graph density, connected components, modularity, average path length, and clustering coefficient, which gives us a framework for understanding each location's image. These are indexes as summarized in the table, ranging from high, medium, and low. With that, these are our results, and we can see that the average degree ranges from 13.699 to 16.064, with Chinatown having the highest average degree and Singapore Zoo having the lowest of 13.699. So overall, we can see that the attractions have relatively high average degrees, indicating dense connections within the semantic network nodes of each attraction. Notably, popular attractions like Chinatown and Malayan are more likely to have discussions focused on specific topics, helping potential visitors access detailed information and travel advice for these locations. Next, graph density. We can see that the graph density ranges from 0.047 to 0.065, with Chinatown having the highest density and Singapore Zoo having the lowest density. These values are generally low, which suggests a moderate overall network density. So attractions with higher graph density may provide a denser information network, offering visitors more comprehensive content, while attractions with lower density may have more scattered information. Next, we look at connected components. So we observe that most attractions have one connected component, indicating a relatively cohesive semantic network that forms a single tightly connected community. So the only exception that we realized was Marina Bay Sands, which has two connected components, suggesting that the semantic network around Marina Bay Sands might consist of different topics or fragmented discussions. Next, we looked at modularity. So the modularity index for most attractions is below 0.44, with Orchard being an exception with modularity of 0.34. This indicates relatively loose partitioning of the semantic network with no clearly distinct modular structures for most attractions. Singapore Zoo also had a modularity of 0.075, which demonstrates particularly loose network partitions, suggesting lack of clear subdivision. And we realized that the discussions related to these attractions are likely more unified and singular in nature. Next, for average path length, it actually ranges from 1.993 to 2.335. So shorter average path length indicates more efficient information dissemination within these semantic networks. We noted that Singapore Zoo had the shortest average path length, suggesting faster information flow, but Little India had the longest, with slightly slower information dissemination. This implies that semantic information related to Singapore Zoo can spread quickly, making it easier for potential visitors to access the information. Next, for average clustering coefficient, it was actually relatively high, ranging from 0.66 to 0.909, indicating that these attraction semantic networks exhibit a high degree of local clustering featuring a small world property. So Singapore Zoo had the highest clustering coefficient of 0.909, indicating tight connections within its neighborhoods, possibly forming multiple close-knitted groups. So Chinatown had 0.798 and Malayan 0.807, also showing high clustering, suggesting that the information within these networks can be easily exchanged within localized groups. This is the image perception semantic network diagram of all 11 scenic spots in Singapore. So we can see that the primary core, which is the main focus terms, include hotels, gardens, free, and parks, which have the highest degree centrality, indicating that they are central to the semantic network and likely represent the core topics of interest for tourists. So the high degree of hotels and gardens suggests that accommodations and natural attractions are primary considerations for visitors, while free highlights the appeal of complementary experiences. We also see recommendations and airports at 91, which also are ranked very high, which shows that the visitors value recommendations for travel planning and the convenience of air travel, which positions Singapore as a well-connected destination. Next, for key attractions and activities, we see that Marina Bay is a major attraction, which is frequently discussed along with experiential terms such as experience and photography. This indicates that visitors place high value on immersive experiences and capturing moments through photos, especially in iconic spots like Marina Bay. We also see Malayan and Universal Studios as well-known landmarks because they have a high degree, underscoring their role as representative symbols of the destination, where they attract considerable attention and serve as anchors in the tourist network. Subsequently, for supporting core, which are the supplementary terms, we see ticketing and food. So these are actually practical considerations, right? Where they frequently discuss about the food options and ticket prices, highlighting their importance in the travel planning process. So high attention to ticketing and food quality reflects visitors' emphasis on logistics and culinary experience as part of their travel. We also see art and choices, where all these terms actually suggest that tourists value cultural and flexible options, showcasing Singapore's appeal as a culturally rich melting pot destination that caters to diverse preferences. Next, for logistics and convenience, we see queuing, activities, and public transportation, which reflect the logistical concerns such as the waiting times and transportation. So a strong focus on public transportation and queue management points to the significance of efficient and accessible services in enhancing visitor experience. We also see trips and itineraries, which are frequently discussed as well, showing tourists' need for structured guidance and efficient planning. So for the secondary core, we see shopping, cabs, and cable cars. So these are terms that are related to shopping and unique transportation options like the cable car, which shows an interest in both retail therapy and distinctive travel modes that enhances the experiences. We also see zoo and aquarium, which highlight the popularity of family-friendly and educational destinations, reflecting Singapore's appeal to a broad demographic including families and nature enthusiasts. Lastly, for peripheral image, we see safety, theme parks, and haunted houses. So, safety and unique experiences like haunted houses suggest varied interests, including a desire for safe and enjoyable attractions as well as adventurous experiences. Finally, night views and marine life reflect niche interests and contribute to the diverse travel options available. Next, so we have the semantic networks for each attraction specifically. These are multi-criteria radar chart analysis by scoring and normalizing activity type, sentiment perception, and semantic performances. So this actually illustrates the profile of these aspects across 11 attractions. So the semantic performance scores incorporates a comprehensive evaluation of the 6 indicators that we have discussed previously. On the multi-criteria radar analysis, let's dive into the data. So from this multi-criteria radar analysis, we see that Sentosa and Marina Bay are the high-performing attractions because they occupy a larger area on the radar chart and exhibit a relatively symmetrical shape, which indicates balanced performance across all indicators. So specifically, let's dive into Sentosa, where it achieved a perfect score in activity type and maintained high scores in sentiment perception and semantic performance, reflecting its broad appeal to tourists due to its diverse activities and positive visitor sentiment. We also see Marina Bay also scored highly in activity type and achieved a perfect score in semantic performance, indicating strong information appeal and structure. These high scores across dimensions demonstrate these attractions' comprehensive appeal and likely higher levels of visitor satisfaction. Next, we see Singapore Zoo and National Gallery are moderate performing attractions because they exhibit a relatively symmetrical radar chart shape which suggests balanced performance across dimensions. So for Singapore Zoo, it performed well in sentiment perception and activity type, while National Gallery excelled in sentiment perception and semantic performance. So although these attractions do not achieve top scores across all dimensions, their balanced performance indicates solid appeal and positive visitor feedback. Finally, we identified lower performing attractions such as Malayan Park and Orchard Road because they only covered small areas on the radar chart and appeared more asymmetrical. So for example, Malayan Park actually scored low in activity type and sentiment perception, reflecting limited activity options and lower emotional appeal. Similarly, Orchard Road scored only 0.2 in activity type, likely due to its primary role as a shopping area with fewer diverse activities. So these lower scores indicate that while functional, these attractions may lack the emotional engagement or variety of experiences seen in higher scoring cultural or natural sites. Now, with the data we have collected, we have provided some recommendations to Singapore Tourism Board. Firstly, we propose for Singapore Tourism Board to expand more free attractions by increasing free or low-cost entry options at key sites to boost accessibility to encourage both tourist and local engagement. Next, from our results, we see that tourists desire for more authentic and local experiences. Hence, we propose for the Singapore Tourism Board to highlight lesser known neighbourhoods like Joo Chiat and Kampong Glam to offer tourists unique and community rooted visits. Next, in terms of the negative sentiments, we found out that queue management was one of the major problems shaping negative sentiments. Hence, we propose for the Singapore Tourism Board to implement digital tools to manage visitor flow at popular hubs like Marina Bay to improve convenience and visitor satisfaction. Next, we also see that tourists desire for more cultural attractions in Singapore. Hence, the Singapore Tourism Board should focus marketing on Singapore's multicultural districts and art venues to attract tourists seeking immersive cultural experiences. Lastly, from our results, we see that tourists desire more self-guided digital itineraries for them to explore Singapore on their own. Hence, we propose for the Singapore Tourism Board to use digital resources using volunteered geographic information to help tourists explore independently, enabling them more personalized and place-making experiences. Now, with our results, we have also developed a website. Here it is. Ladies and gentlemen, welcome to Singapore. This is our Singapore travelling website. Over here you can see the top 11 tourist attractions in Singapore. Now let's explore our webpage of Marina Bay Sands. Here, tourists can click on any of these Xiaohongshu posts and this will then link them to Xiaohongshu to read the tourist recommendations. And over here, we summarize the activities that tourists can participate in, and this is also summarized in a pie chart format. And here you can see the tourist sentiments of Marina Bay Sands and also the semantic network analysis. Let us do this for other tourist attractions such as National Gallery Singapore. So we hope that this website allows you to explore Singapore in a unique way.